In this Maths in Motion video on complex numbers, it's all about Euler's formula. As a bonus, my nephew Jelle will make a mural of the most beautiful expression in the whole of mathematics. How about that? So let's start right away. You know that you can represent a complex number as a point in an xy plane. A is located on the real axis, the horizontal, and B on the imaginary axis, the vertical. You call this distance r the modulus and this angle theta the argument. From the drawing it will be clear that the cosine of theta equals this adjacent side divided by this hypotenuse. So the cosine of theta equals a over r. From this it follows that a equals r times the cosine of theta. The sine of theta equals the opposite side divided by the hypotenuse. So the sine of theta equals b over r. And from this it follows that b equals r times the sine of theta. With these results you can write a complex number z as r cosine theta, because that is a, plus r sine theta times I. Or, with r outside the brackets, z equals r times cosine theta plus I sine theta. The famous mathematician Euler has shown that this term between brackets, cosine theta plus I sine theta, equals e to the power I theta. So, using Euler's formula, you can write a complex number z as r times e to the power I theta. Always make sure that you use radians for theta, otherwise the formula will give faulty results. Euler's formula leads to the most beautiful expression in the whole of mathematics. According to the celebrated physicist Richard Feynman, that is. And who am I to disagree? Here I have written down Euler's formula once again. E to the power I theta equals cosine theta plus I sine theta. Suppose you substitute pi for theta. You get e to the power I pi equals cosine pi plus I sine pi. You probably know that cosine pi equals minus 1 and that sine pi equals 0. So the formula becomes e to the power I pi equals minus 1, or e to the power I pi plus 1 equals 0. This is a most remarkable result. This extremely compact formula combines the three mysterious constants e, I and pi together with the two most important natural numbers 0 and 1. E, I and pi that each come from very different mathematical areas. Unbelievable, isn't it? I mean, that's something worth writing on the wall. Thanks, Jelle.